Hi all, in this video we are going to talk about decision tree classifier. So to start, we import the required libraries like NumPy, Pandas for data manipulation, and scikit-learn for metrics and utilities, and Matplotlib for visualizations. Next, we are going to load the diabetes dataset to train and test our model. So it basically contains patient data and a target variable indicating whether they are diabetic or not. Finally, we normalize the features using min-max scalar to bring all values between 0 and 1. This helps the model coverage faster and improves performance. So splitting the dataset, we're gonna do it in 80 is to 20 ratio. Therefore, 80% of the data is used for training and 20% is reserved for testing. Therefore, this ensures the class distribution in both sets remains the same. So now comes the interesting part, building the decision tree from scratch. Let's start with Gini impurity function. This measures how pure a node is, with lower values indicating more homogeneity. The decision tree is built using nodes. Each node has attributes for the feature it splits on. The threshold for splitting, the pointers to itself and right children, and if it's a leaf node. These are the key characteristics that we have to keep a note of. So the decision tree class orchestrates the entire process from growing the tree to making predictions. So the first thing is fitting the tree. This method initiates the tree building process by calling growTree. This is where the recursion magic takes place. Therefore, the growTree method recursively splits the dataset until a stopping condition is met, such as reaching the maximum depth or having fewer samples than minimum split size. Then finding the best split. So to determine where to split, we evaluate every feature and threshold, choosing the one that maximizes the Gini index. The Gini gain measures how much a split improves the purity of the data. So once the tree is built, predictions are made by traversing from root to appropriate leaf node. And next comes the training and evaluation. So we train our custom decision tree with maximum depth of 10 and minimum split size of 5. So after training, we predict on test set and calculate performance metrics like accuracy, precision, recall, and F1 score. So let's see the results by visualization. This is the condition matrix, therefore actual and the predicted values relation, and this is the ROC curve, therefore false positive rate versus true positive rate, and the feature importance, which feature is important, therefore importance versus feature scrap, and class distribution, which highlights the frequency in class 1 and class 0, and this is the feature distribution by class. This is the class 0's feature distribution, and this is class 1, and this is class 2, and so on based on various classes. And this is the precision versus recall curve, and we can also see the cumulative gain chart, therefore the sample versus cumulative gains. Yeah, that's all. Thank you.